Hello everyone, my name is Pranay and today we're going to start on our journey to study physics. Till 11th means when you were back in 10th grade, you must have studied science, but science was not officially partitioned into the three subjects physics, chemistry and biology, right? So today, before getting into anything technical, I would like you to pay attention here so that I can instill in you the same interest and favoritism that physics has in my heart, right? So we all play games, right? Or we used to play games. Some of you must be that disciplined that you dropped your games for your studies to focus on these 2 years of our prep, right? But everyone has played a game or two in their lives, right? Be it online games, games on your phone, games on your PC, or board games, or like physical games like hide and seek, or some sport like basketball, football, right? Everyone has played some of the other game. Do you know all the rules of the game before you start? Not necessarily, right? Some of us start playing the games and then learn the rules as we go, right? So if we talk about my favorite game is chess, right? My favorite game is chess, and my favorite game is chess because I had a very cool elder brother. You must have, everyone has it, that older sibling or some friend who they think are very cool, and we like to share all their hobbies and do everything together, right? We want to be their friends, but usually they're too cool for us and they do not want to give us time, right? So I had a friend of mine who was the son of my dad's friend, and he was really good at chess. Okay, he was like 3 or 4 years older than me, and he used to play chess with all the friends, all of his school friends that came over, and he used to play chess online, and his rating was really good. I think it was above like 1500 at that time on chess.com, right? So it was really good. Okay, so basic intro to chess. Do you know what these pieces are? Okay, this is the king, this is the queen, this is the bishop, this is the knight, this is the rook, and this is the pawn, right? So here we have a chess board, and here we place all the pawns of one side and all the pieces of one side here, and similarly for the other side, right? So if this is black and this is white, all the pawns of the black, all the black pawns will be right there. Let's choose like, okay, so let's say this is the what, black pawn. All the black pawns will be here, right? Now who sits here? Here's the rook. The rook's on both the corners, right? And then the knight, then the bishop, and the black queen stays on the black square, and the black king stays on the white square. Okay, similarly for white, oh, that's not visible, I guess. The pawns will be here. The rook will be here. The white queen on the white square. Right. So this is a basic view of how the chessboard looks like when the game is starting. Okay. So I did not know that it looks like this. Okay. Try to keep yourself in my shoes and try to think that you are trying to learn the game of chess without ever knowing the rules or having access to any other external source of information that already has the chess rules. Okay, so think you're in my shoes and you're watching the game that my elder brother is playing with his friends, right? So what does he do? First of all, he brings out his pawn right here. With this observation, what can you presume? That the pawn can be moved ahead one space. Can it be moved ahead two spaces? We don't know yet. Next move, this guy brings out his pawn and places it here. Now we know that the pawn can be moved two spaces, but can it move three spaces? We don't know for sure yet. I watch a lot of games, okay? The pawn never moved three spaces. So we can assume that the pawn cannot move three spaces ahead, okay? But then what happened? This pawn was right here. This pawn was right here, and this pawn was right here. Now theoretically, what we have assumed that the pawn can only move ahead in straight lines, right? But what my brother did, he captured this pawn like this and moved his pawn right here. So we found out two new things. What? That we can capture other pieces of the player and pawn captures like this. If I would have not seen this happen, would I have been able to assume that this rule existed? No, right? So I thought that I was a big shot after I learned all the moves of these, all the basic moves of these pieces, right? I thought I was some hotshot and I challenged my brother. Okay. The first thing he did, when I moved my pawn right here, let's say my pawn was somewhere here, right? I had just moved it. So my previous move was this, and I wanted to move this pawn ahead to take out my queen or something, whatever the reason was, and his pawn was already here. Okay. So and my pawn was here. So I thought, oh, I blocked this pawn, okay, and I had moved this pawn. I wanted to move this pawn. I could have moved it right here, but why did I not move it right there? Because I did not want it to get captured immediately. Okay, if I moved it right here, he would come here and capture me, right? So I moved it two spaces ahead. Do you know what he did? His next move was this. He placed his pawn here and captured my pawn like this. I thought he was cheating. I found out he was not. Why? Because this is a rule called en passant in chess, where you can cut a pawn, where you can capture a pawn as if that has moved two spaces, as if it had moved only a singular space. So you see why I could have never guessed that he would have made such a move, right? Because I did not have enough observations made. So physics is a similar study of the nature and its laws. Okay, what we do is exactly this. We observe what is happening around us. We observe all the natural phenomena that is happening around us, and we then try to figure out what the rules or the reasoning behind this huge game of chess that we are watching are. Okay, we try to figure out what the laws of nature are, right? So this analogy of the game of chess with the game of nature and us guessing the rules and a physicist guessing the laws or figuring out the laws of nature, this analogy was given to us by Dr. R.P. Feynman. He was a renowned physicist and a very intelligent guy. Okay. One of the other things he has said is this beautiful quote right here. Nature uses only the longest threads to weave her patterns so that each small piece of her fabric reveals the organization of her entire tapestry. Okay, for those of you who don't know, tapestry is a curtain. Okay, you can assume that it's a curtain. It was used back in medieval times. Some people still use it now for decoration. It's like a very large piece of fabric that is hung on walls ornamentally. Okay, so the tapestry is woven out of threads, right? And it has a specific organization or a specific pattern in which those threads are woven. So what Feynman is trying to say here is that the tapestry that you have woven, even if you take out a single thread from that, okay, you can figure out the pattern that the tapestry has been woven in throughout the structure of the tapestry. Okay, what he's trying to actually mean is that in nature, when Isaac Newton observed that the apple is falling from the tree to his hand, he discovered what? The laws of gravitation, right? The force of gravity that every object exerts on every other object, right? Those same laws were applicable to what? The motion of heavenly bodies. So a single thread can reveal the organization of the entire tapestry as well. This is the beauty of physics. Okay, so we are going to be studying very basic things and they would apply to a larger extent in your life. That is why physics is my favorite subject and it is the closest we can get at this level to exact science. And physics is a very amazing subject and I promise you that you will all love it. Now coming up to writing these rules actually. So we have to write these rules somewhere, right? Or else Newton gave us some laws of gravitation. And if we don't write it anywhere, how would you know, how would I know what the laws of gravitation are? We would have to discover them all over again to make use of them, right? How do we make use of rules? You know how to play chess, you can play better chess, okay? You can survive better in chess, you can survive better in nature if you know more about physics, right? Everything around us, like the AC in this room that is keeping me at a comfortable temperature, so I am able to deliver this content, the internet that you are using, everything is based on the concepts of physics. At a very basic level we started, and together with the use of physics and the knowledge of science, we grow to the society that is here today. Okay, so we need to write these rules down somewhere so the upcoming generations can read them and make use of them to make our society even better, even modern, right? So how do we actually write these rules? We could write them like this, right? Sir, whatever rules you find out, just write them down. Okay, so I wrote them down for you. The displacement of a uniformly accelerated particle is equal to the sum of the product of the velocity to the time passed and half of the product of the acceleration and the square of the time passed. Oh my god, what is this complex rule? Do you know this? What if I told you know this? The displacement, so S, uniformly accelerated particle is equal to the sum of the product of the velocity to the time, and the half of the product of the acceleration, and square of the time passed. We've studied this equation, right? It is the equation of motion, second equation of motion, right? And what is this? The force applied on a particle causes an acceleration equal to the magnitude of the force divided by its mass. So acceleration is equal to F by m. Do you not see that this is actually way simpler than this? Can you see that? Okay, maybe you say that we can write it like this and we can use it like this. So we can maybe write these laws like this. Okay, so you're saying that if we remember these laws, We don't have to remember these laws. Okay, let's see what happens next. How can we relate these rules to each other? So we know that what the displacement is, we know what the acceleration is if there is a force acting on the particle, right? So if I were to tell you the force that was acting on the particle and I asked you about the displacement, you would have to use a different law, that is this. The displacement of a uniformly accelerated particle is equal to the sum of the product of the velocity to the time passed and the half of the product of the acceleration, which is the force applied on the particle divided by its mass and the square of the time passed. This was so difficult to read that I lost my breath. So why have we created physics? Because it's convenient for us. Is this convenient? Does this look convenient to you? It does not look convenient to me. What we could have easily done is, we could have put this acceleration right here, and this would have come out to be like so. This is so much simpler, right? So much simpler. And we prefer using this. So that's why we say that mathematics is the language of physics. Why? Because the freedom to use mathematics in physics makes expression relation here, this was a relation between these two expressions, right? Of the laws of nature and makes prediction of natural phenomena based on these rules much more convenient. Okay. So to learn physics properly, to grasp the nature of physics, we need to be able to use some basic mathematical tools, okay, so such as algebra and binomial theorem, trigonometry, logarithm, calculus and vector mathematics. Okay, we'll talk about vector mathematics later when we go on to the chapter motion in plane, but right now we'll touch up all these topics. Okay, so algebra, you know what is algebra? All the operations that you perform on numbers, addition, subtraction, multiplication, division. Binomial theorem also comes under algebra. All the real numbers come under algebra. All the identities you need to know are in algebra. What were the basic identities? A plus b whole square is equal to a square. A plus b whole squared is equal to a square plus b squared plus 2ab, right? So everything is simple. We don't need to go into the algebra, okay? We don't need to go into the depth of any mathematical topic. We just need to be able to use them as tools in our pursuit of physics and the knowledge about the nature and its laws, okay? So we just have to use this as a tool to get there, to get to our application. We just have to apply them, right? Okay, so a branch of algebra is also considered with a binomial theorem. You must have studied binomial theorem in class 10th, right? What was it? It allowed us to expand a plus b to the power n, right? So what was it? NCR selection, right? This was called n factorial upon r factorial, n minus r factorial, and you remember what factorial was, right? We can write it like this, or we can write it like this, and it's simply n into n minus 1 till 1, right? So we used to write this expansion as a plus b to the power n, NCR, and NCR, and a to the power n, and n minus r, and b to the power r. Okay, this was a general term, and the summation of all these terms was this expansion. Right? Okay. So the use of this in physics is just an approximation. What if there was an expansion that said 1 plus x to the power n, and we know that x is a lot smaller than 1, then this can be expanded as 1 plus nx. Okay? So this is the important takeaway from this basic expansion. Okay, even this is important, but you won't be requiring this as much as you require this. Do you know why this happens? Because the first term will be 1 to the power n, x to the power 0, right? The second term will be 1 to the power n minus 1 will be still 1, and this will be still 1. So the first term will be 1, the second term will be 1 to the power n minus 1, which is 1, into x to the power 1 x, and into nc1, which will be n factorial by n minus 1 factorial and 1 factorial. So this will come out to be n, because this is 1 into 2 into 3 into 4 till n, and this is till n minus 1, so only an additional n will be there, so an n will be multiplied here, and in the next term the power of x will increase till 2, which is very small compared to this number, because x is very small compared to 1. So an approximation will come out to be like this, okay, which is this. All right, so moving on to the next, trigonometry. We studied a lot about trigonometry as well in class 10th. Okay, do you remember what it was? We talked about triangles in trigonometry, right? So let's say I have a triangle ABC. And it's a right angle triangle. And here's an angle theta. Okay. So the side opposite to the theta, what do we call it? The altitude or the perpendicular. So this AB is the perpendicular, okay, and BC is the base, and AC is the hypotenuse. Right? So we had some basic trigonometric ratios that were sine theta, that was perpendicular upon hypotenuse. So P upon H, perpendicular is AB and hypotenuse is AC, right? And then we had cos theta, which was base upon hypotenuse, right? And this was base is BC and hypotenuse is AC, right? Then we had tan theta, which was perpendicular upon base. Perpendicular was AB and base was BC. Right? Then we had the reciprocals of these ratios as well. Sin theta had its cosec theta. Cos theta had sec theta and tan theta had cot theta. Right, these were the basic trigonometric ratios. And then for some basic angles we had some values as well. So for 0 degree sin theta was 0 and for 30 it was 1 by 2. For 45 degrees it was 1 by root 2 and for 60 degrees it was root 3 by 2. For 90 degrees it was 1. Okay, and cos theta was the reverse of this. Okay, so for 90 it was 0. So for 90 it was 0 and for 0 it was 1. For 30 degrees it was root 3 by 2. For 45 degrees it was 1 by root 2. For 60 degrees it was 1 by 2. So you had only to remember the sin theta values. The tan theta would be, sin theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse. So tan theta would be perpendicular upon base, so tan theta would be sin theta upon cos theta. So we can remember this by dividing sin theta by cos theta. 0 by 1 would be 0. 1 by 2 by root 3 by 2 would be 1 by root 3. 1 by root 3. Okay. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2, this will be root 3. And this will be not defined because division by 0 is not defined. Again, this rule is a part of algebra. Okay. That division by 0 is not defined. Cot theta would be the reciprocal of this. The reciprocal of 0 is not defined. Okay. And also the reverse of this, right? The reciprocal of 1 by root 3 is root 3. 1 is 1. This will be 1 by root 3. And this will be 0. Okay. Now sec theta will be the reciprocal of cos theta. So this will be 1. This will be 2 by root 3. This will be root 2. This will be 2 and this will be not defined. Okay. Sin theta would be not defined here and then 2 here. Okay. And then root 2 here. Then 2 by root 3 here and 1 right here. Okay. So these are the basic angles, the basic values, trigonometric ratios of the basic angles, and you need to learn only this. Okay. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Okay. Cos theta is exact opposite of that. Tan theta is this divided by this, and then cos theta, then cot theta is the reciprocal of tan theta. Sec theta is the reciprocal of cos theta. Cosec theta is the reciprocal of sin theta. So this is an easier way to learn these ratios. In physics, there is another triangle that we consider. Okay. This was equilateral triangle. Okay. When we draw an altitude, we found out about 30 degree. Okay. Then 0 degree and 90 degrees, we can guess, we can kind of work out what the ratios will be for this. 45 degree was simply an isosceles triangle because 45 degrees and then 90 degrees, that's an isosceles triangle. Okay. So there's also another triangle in physics that we approximate for the values for. Okay. So let's say this is our triangle. What what is the most common Pythagorean triplet that came around in your books in 10th? Pythagorean triplet, you know, right? In a right angle triangle, what is there? That a square plus b square is equal to c square, where these two are the arms of the right angle triangle and c is the hypotenuse. Okay, so which was the most common thing that you saw in your textbooks? I'm sure you all saw this triplet, right? Three, 4 and 5. So we considered this triangle. Okay, so this side is 3, this side is 4 and this side is 5, and the approximate value of these angles are, this is 53 degrees and this is 37 degrees. Okay, these are not the exact mathematical values for these angles, but in physics we approximate them to be like this. Okay, so quickly let's review. This would be perpendicular. Let's name this triangle, ABC was the last one. Let's name this triangle D, E and F. Okay, so what was sine theta? Sine theta was perpendicular upon hypotenuse. So PE upon DE upon DF, right? So D is 4 and DF is 5. This was for 53 degrees. Okay, and DE is the perpendicular for 53 degrees, and this same line is the base for 37 degrees. So this will be cos 53, cos 37 degrees, right? And then cos 53 degrees would be EF upon DF, right? So 3 by 5, this will be sine 37 degrees, and tan 53 would be perpendicular DE upon DF, which is 4 by 3, right? And this is cot theta for 37 degrees. So let's simply write tan 37 will be the reciprocal of this, which is 3 upon 4, right? So what are the additional values that we learned? Sine 37 is equal to 3 by 5, cos 37 is equal to 4 by 5, and tan 37 is equal to 3 by 4. Similarly, sine 53 is equal to 4 by 5, cos 53 is equal to 3 by 5, and tan 53 is equal to 4 by 3. All right. Let's look at this question. If the angle of elevation is 30 degrees, how high does a ladder reach if it's 10 meters from a wall? So what have we given here? Ki the angle of the elevation. What was the angle of elevation? Let's see if we can draw a ladder here. So this is our wall. Okay. This is our wall. and we have a ladder that is resting here. Alright, and the angle right here, they are saying that this angle is this angle right here is 30 degrees. Okay, so how high does a ladder reach if it's 10 meters from a wall? So the wall here, the distance is 10 meters, and it's asking what this height is. Okay, so this is what? Tan theta. This is tan theta, right? And tan 30 was what? One by root 3. Tan 30, 1 by root 3. Right? And this is 10 meters. Okay. So the height will be h by 10 is equal to 1 by root 3. The height will come out to be 10 by root 3. And root 3 is around 1.7. Okay, and if we try to find out the height will come out to be 10 by root 3. And I think this question is asking us the length of the ladder, because its angle is 30 degrees. Okay, so if the angle of elevation is 30 degrees, we just have to find out the height, which will be 10 by root 3. Okay, and this is 1.7. So if we do the division right here, so this is coming out to be somewhere around 5 meters. So this will be our answer. Okay. Next, at a certain time of the day, the sun is seen at the angle of 45 degrees. If the shadow of a pole is 10 meters long, what will be the height of the pole? Okay, again there is the same question. This is our pole, and the pole is casting a shadow right here because the sun is somewhere around here. There is a sun somewhere around here, right? Alright, so because of this sun, the shadow of this light, there is light coming here on this pole, and it's casting a shadow right here, and the angle of elevation is given to be 45 degrees. Okay, and the shadow of the pole is 10 meters long, so this is 10 meters long. So it's asking us about the height of the pole. What ratio is this? Tan theta. Tan theta is tan 45 degrees. Tan 45 degrees is 1. Okay, 1. So perpendicular, the height of the ladder, the height of the pole upon the distance. 10 is equal to 1. So height is equal to 10 meters. This is correct. And you can apply basic geometry here as well, that this is 45 degrees, this is 90 degrees. So the sum of the angles in a triangle is 180 degrees. So this must be 45 as well. If these two angles are 45 degrees, these two sides are of the same length. So because it's an isosceles triangle, so this is 10 meters, so this will also be 10 meters. Okay. The farmhouse shown in figure has rectangular shape and has sides parallel to the chosen x and y axes. The position vector of corner A is 125 meters. So this is 125 meters long and the angle is 53 degrees. Okay, so what we'll do here is, let's project a line right here from A to the x axis. Okay, and let's project a line right here from B to the x axis. A, B, C, D, let's name this O and this E and F. Okay, so let's consider the triangle AOE. The angle is 53 degrees. I told you about this triangle, right? 53 degrees. This side is taller. So this is for some ratio x. This is 3x and this is 5x. Okay. So what is given? AO is 125 meters. Okay. So 5x is equal to 125. So x is equal to 25. Okay. So AE is equal to 4 into 25, that is 100 meters, and EOE is equal to 3x, 3 into 25, that is 75 meters. Right. Now next what we'll do, we'll consider the other triangle. Okay, what was this triangle? Let us use a different color for this triangle. What is this triangle? We'll choose this triangle C, F and O. Okay, so we can make use of this 37 degrees right here. Okay, so this is CFO. It looks something like this. Right, it looks something like this. Okay, so C, F, and O. And this angle is given to be 37 degrees. So again, let's say the ratio conversion unit here is y. Okay, so this is 4y, this is 3y, and this is 5y. Right. So what is given? This CO is given. Right, 100 degrees at 37, 100 meter at 37 degrees from the x-axis. So 5y is equal to 100, y is equal to 20, then 4y is what? OF. So OF is equal to 80 and CO is equal to 60. All right, so what did we have to find out? We had to find out the length of the fencing that was required in meters, right? So we know what AE is now. AE is 100 meters and OE is 75 meters and OF is 80 meters and CO is 60 meters, right? So CD we can find out 80 minus 75, so this is 15 meters, and AD we can find out this is 80 minus 60, that is 20 meters, right? So the perimeter of this is the length of the fencing required. So what will it be? Perimeter is of a rectangle 2 into L plus B, right? So 2 into 15 plus 20 is 35, that is 70 meters. Alright, so these type of basic questions you might have done in class 10 as well for trigonometry, right? And you might have faced a lot of difficulties during this subject, this topic of mathematics. You always studied and then you cried. Why? Because you tried to memorize a lot but you could not because of some or the other reason. So I'll try to make it as easy for you to remember. You know, you remember those identities which were like sine 180 minus theta, and then it was something else, and then cos 180 plus theta was something else, and then 360 minus theta was something else, right? We had to remember all those stuff. Okay, we won't have to anymore. So this is actually an acronym which you can use to learn a lot of things as well, like you can memorize something else as well. Okay, so this is we'll move from the first to the fourth quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Let's write it like this: A, S, T, C. So this circle right there is a unit circle. Okay, it has a radius 1 meter. What is the radius? It is the distance from the center to any point on the circle. Okay, so if we take an angle right here, in anti-clockwise direction, if we take an angle right here, every angle that will come within this quadrant, every ratio of it would be positive. All ratios would be positive. In this quadrant, only the sine ratios will be positive. Everything else would be negative. In this quadrant, only the tan ratio will be positive, or the cot ratio will be positive. Similarly, here also the cosec ratio will be positive, and here only the cos and the sec ratios will be positive. Okay. So for the next session, we'll learn about differential and integral calculus. That will go just over it briefly, and you will study about calculus in depth in mathematics in class 12. So right now we'll stop right here at trigonometry, and we'll study about calculus in the next session. Okay, so what did we learn today? Physics is the study of nature and its laws. The freedom to make use of mathematics makes the expression and correlation of physical laws and the prediction of physical phenomena based on these laws extremely convenient. And there are some mathematical tools like algebra, trigonometry, calculus, and vector mathematics that are very important to use to perfectly use these laws. Okay, so that's all for it today. Thank you.